Welcome back. In this mini lecture, we will look at service orientation in the public sector. As already mentioned in one of the previous mini lectures, we can differentiate between different levels of service orientation. The first one is the individual service orientation. The second is the organization's service orientation, and the third one is the architectural approach, which is also known as service-oriented architecture. It includes the notion of implementing business processes as software services. Software services and systems are loosely coupled components which goals is to support well-defined business tasks. Systems with modular business services ensure more efficient and flexible IT systems. The concept service orientation itself addresses the issues of adaptability and flexibility. Service orientation is the ability and desire to anticipate, recognize, and meet others' needs. In our case, it's the citizens' and other stakeholders' needs. Sometimes this even means that the needs have to be anticipated even before those needs are articulated. Service orientation is a way to use the modularity of key businesses and to make sure that well-defined interfaces are designed. In turn, they would help ensuring that services work in different situations. Move to service orientation is an evolving process. Service orientation is also a business approach and methodology. Using a service-oriented approach helps businesses adapt to change and make scalability possible. Service orientation lets companies and organizations leverage existing assets and create new business services that are consistent, controlled, and more easily changed and managed. As a result, a service-oriented approach leads to business goals consistent with demands of cloud computing environments. However, service orientation is not only about technology and its adaptability and flexibility. As said before, it is also about communities, customers, shareholders, partners, and employees that are connected to the extended network of one organization. Service orientation is about processes that span and integrate all these communities. One very simplistic suggestion that can be derived from the notion of service orientation is as follows. The way in which service orientation can be developed is by, firstly, thinking about the customer. Secondly, focusing on improving the level of service one provides and identifying the cons and pain points. Thirdly, setting clear and measurable set of goals and benchmarking them against previous situations, services. And lastly, revisiting the goals once changes have been made. But now more closely about SOA. Service-oriented architecture is a business-driven IT architectural approach that supports integrating a business as linked repeatable business tasks or services. It helps innovation by assuring IT systems can adapt quickly, increasing flexibility of business processes, strengthening underlying IT architecture, and reusing their existing IT investments by creating connections among disparate applications and information sources. The above, in turn, helps address increasing complexity, need for lowering development, integration, and maintenance costs, and obtain sustainable competitive edge through technology. SOA begins with a service that could be a simple business task such as checking the credit rating of a potential customer. The essence is really that SOA is based on the concept of a service. Depending on the taken service design approach, each SOA service is designed to perform one or more activities by implementing one or more service operations. Each service is handled as a discrete piece of code. This makes it possible to reuse the code in different ways throughout the application by changing only the way an individual service interoperates with other services that make up the application. This means that within SOA, services use defined messages using description metadata, which in sufficient details describes not only the characteristics of these services, but also the data that drives them. There is extensive use of XML in SOA to structure data that they wrap in a nearly exhaustive description container. The purpose of SOA is to allow users to combine together fairly large chunks of functionality to form ad hoc applications built almost entirely from existing software services. SOA as an architecture relies on service orientation as its fundamental design principles. This means that a service presents a simple interface that abstracts away its underlying complexity. Then the users can access independent services without knowledge of the services platform's implementation. The main benefit of SOA is that it allows simultaneous use and easy mutual data exchange between programs of different vendors without additional programming or making changes to the services. These services are reusable, resulting in lower development and maintenance costs and providing more value once the service is developed and tested. Having reusable services readily available also results in quicker time to market. There are no industry standards relating to the exact notion of a service-oriented architecture, although some principles have been published. Firstly, service loose coupling is a design principle that is applied to the services in order to ensure that the service contract is not tightly coupled to the service consumers and to the underlying service logic and implementation. This results in service contracts that could be freely evolved without affecting either the service consumers or service implementation. Secondly, service reusability is also a design principle that is applied within the service orientation design paradigm in order to create services that have the potential to be reused across the enterprise. These reusable services are designed in a manner so that their solution logic is independent of any particular business process or technology. Service autonomy is similar to the previous two, and this means that it provides services with improved independence from their execution environment. This results in greater reliability since services can operate with less dependence on resources over which there is a little or no control. Service discoverability emphasizes on making services discoverable by adding interpretable metadata to increase service reuse and decrease the chance of developing services that overlap in function. By making services easily discoverable, this design principle indirectly makes services more interoperable. Service abstraction is applied so that the information published in a service contract is limited to what is required to effectively utilize the service. This means that the service contract should not contain any superfluous information that is not required for its invocation. No other document or medium should be made available to the service consumers other than the service contract that contains additional service-related information. And lastly, standardized service contract is applied in order to guarantee that the service contracts within a service inventory, enterprise or domain adhere to the same set of design standards, which results in standardized service contracts across the service inventory. Now, we will also briefly cover the sense of SOA metadata. In essence, it means data about data. We can bring out a couple of types of metadata. The first is structural metadata, which is the design and specification of data structure. This is the data about the containers of data. The other one is descriptive metadata, which means the individual instances of application data. This is the data content. Metadata are stored and managed in a database which is called metadata registry or repository. Metadata are defined as data providing information about one or more aspects of the data. For instance, the means of creating of the data, the purpose of the data, the time and date of creation, who is the creator of the data, what is the location of a computer network where the data is created, and what are the use standards in this matter. Within SOA, services use defined protocols that describe how services pass and parse messages using description metadata. That metadata describes the characteristics of these services and the data that drives them. SOA depends on data and services that are described by metadata. Should be provided in a way so that it could be used by other applications, like a catalog to perform auto-discovery of services. Should be also provided so that the system designers can understand and manage these with a reasonable cost and effort. Thank you for listening and stay tuned for the coming mini lectures.